Okay, so I am on page 665 in your math book, and we're talking about scatter plots. So here's just some quick vocab review. So recall that the graph of a linear equation is a line on the coordinate plane. The slope of the line describes the direction and steepness of the line. On the coordinate grid shown, graph and label two lines. One line should have a positive slope and one line should have a negative slope. So if we want to have a positive slope, our line, reading it from left to right like we would a book, needs to increase. So that would be a positive slope because looking at it left to right, it goes up. To have a negative slope, I need to read it left to right and make sure it goes down. So that would be a negative slope. If we're looking at this real world link right here, the table shows temperatures in degrees Celsius and Fahrenheit for a local weather station. We need to graph the ordered pairs. It tells us that Celsius is X and Fahrenheit is Y, so I might label that on my table. Is the slope of the line passing through the points positive or negative? So again, these are my X's, these are my Y's. If I go 0, 32, it'd be about here, because this is an ordered pair. And then this is an ordered pair, 5, 41, it's about there. 10, 50, 15, 59, so just short of 60. 20, 68. 25, 77. And 30, 86. So if we were to connect those points, in a scatter plot you don't actually connect the points, but if we were to connect those points, we can see that it is going up when reading it from left to right, therefore it has a positive slope. All right, moving on to the next page. All right, just some vocab up at the top. When we're constructing a scatter plot, data with two variables, which we've been doing X and Y, or pairs of numerical observations are called bivariated data. So remember when you talk about a bicycle, you have two wheels. So bi means two, so bivariated data means two variables in the data. A scatter plot shows the relationship between bivariated data graphed as ordered pairs on a coordinate plane. For example, the bivariated data set year and number of visitors can be displayed as a scatter plot. So that's just an example. I'm going to skip through example 1, and I'm just going to do got it A with you. So please follow along and write this in your book. So we need to construct a scatter plot of the weight of an alligator at various times after hatching. So first of all, let's label our table. Weeks. You can see that looking at the weeks, that's probably going to be our x-axis because it goes all the way up. Our x-axis goes to 50 and our largest number is 49. So this is our x and this is our y. So make sure we label our x and y axis too. So x represents weeks, y represents weights in pounds. Okay? Then we just graph them. So the first one is 0, 6. Then we have 9, which is about 10, not quite, and 8.6, so just a little bit above 8. 18, 10, so closer to 20 than 15, and then go up to 10. 27 and 13 and 6/10, so I go over in between 25 and 30, and I go up in between 12 and 14. It's okay if they're not exact. 34, 15, so just shy of 35, just shy of 16. 43, 17 and 2/10, so over here, 43, just shy of 18. And then 49 and 19 and 8/10, so just shy of 50, and then go up to that there. So again, scatter plots, we do not connect the dots. It's just dots showing the different representations of the weights per weeks for alligators. So do not connect it. It's not a line graph. So that is our scatter plot. All right, so now that you've watched video 1, you're going to go to the choice board and you're going to select one of the appetizer options. So you select one of them and construct a scatter plot based on the information you gather.